Before we start with the topic rigid body dynamics, why don't we start with the most basic, such as V equals to ds dt, A equals to dv dt, and stuff like that. Like what I just wrote down, we have similar equations for angular motion, like what I'm writing down now. And when you have constant acceleration, don't forget about these equations. These equations I'm writing down look familiar, don't they? Because you should know them! I'm just kidding. Just remember them and be prepared for what's coming next. Now that you've revised, we're back on track and ready to learn some more stuff. And these stuff I'm talking about can get pretty hard. And like all hard stuff in engineering, we need to go back and use the equation F equals to ma. Oh. So how do we apply F equals to ma on rigid body dynamics? So we have a cat here, and there's forces going everywhere. Some going out, some going in, and not necessarily acting on the center of gravity of the cat. But now if we add all the forces together and force it onto the center of gravity of the cat, we also get a moment around the cat as well. Now we have two equations to work with. F equals to ma and m equals to I alpha, where m is moment, I is moment of inertia, and alpha is angular acceleration. Knowing this, we can do this question here. A rod of mass 15 kilograms is linked to the wall with the links dB and links CA. A moment of 5 kilonewton meters is acted on the link CA. So we can mark our axis N and T and do the sum of forces to find out the force acting on A, which turns out to be 3.33 kilonewtons. We can write our F equals to ma equation now, with the force of A, the weight of the beam, and also the acceleration of the beam. Rearranging, we get alpha. And if you remember the revision, we can integrate the equation, which leaves us angular velocity squared and angular acceleration. So now we can work out the normal acceleration and also the tangential acceleration. And finally, using the moment equation to find out force of B. Now we can use work and energy to work out rigid body dynamic questions. Anything that moves or has weight has energy, so we can use these properties to our advantage. First, we have translational energy, which is T equals to half mv squared. Rotational energy, half I omega squared. Gravitational potential energy, mgh. And elastic energy, half kx squared. We can combine all these equations together to make something magical. Let's have an observe at this hollow tubing that's rolling down a ramp. So first we write down the equation. Work equals to kinetic energy plus potential energy plus elastic energy. And we know that potential energy and elastic energy is equal to 0. So we can just write down T equals to half mv squared plus half I omega squared. Then we know that its energy is equal to mv squared. And finally we can work out the velocity. Let's do one more hard example. Oh wait, look at the time. How unfortunate. I made this video